All right, today we're talking about adding and subtracting fractions. So I want to do a basic example first. When we're adding and subtracting fractions, the most important thing you have to check for is the common denominator. What that means is, are the two fractions the same size slices? What I mean by this, let's look. Whoa. In this case, we have 1/4 and 2/4. When we add these together, both of them are the exact same size pieces, so we can actually add them together really easily. It's like saying if I had one shoe plus another shoe, or plus two shoes. Because they're both shoes, they're like terms, they make sense to go together, so it's easy, you just add them. If they're different, like, oh, where's my example? There we go. Like something like that, where they're different numbers, we actually have to do another step, and we'll get to those in a minute. So, in my example here, I have 1/4 plus 2/4. The idea is we want to think, what's our final answer going to be? A lot of students, the top number makes sense. You have one piece plus two pieces means you have 3. A lot of students will mistakenly write 8 as the denominator because they've added them together. This is wrong, and I want to explain why it's wrong. The idea is that this is just the size. It represents the size of the fraction. So when you have two sizes, you don't actually add the sizes together. They're just telling you how big the slices are. So when you add them, you're actually only adding the top number because that's how many pieces you actually have. The size actually stays the same. Because we had 1/4 and 2/4 means we have 3/4. The size didn't change. That's it. Oh, and the picture would look like this. 1, 2, 3 colored in. Let's try a different example. 3/5 plus 2/5. Well, had the answer down there. Okay. Again, both the denominators are the same. They're both the same size slices. So when we add them together, this just becomes, This just becomes, I'll do it red. 3 plus 2 is 5 out of 5. And then now we can actually reduce it if you want. You could divide them both by 5, which would give you 1 out of 1, which is the same as 1. And I want to show you why, because let's say we had our circle and it was cut into 5 pieces. If they were all colored in, we would have an entire circle colored in, which would mean we have 1. Okay? Whenever you have a number divided by itself, it actually turns into 1. This is a different example, same basic idea. 3/5 plus 4/5. So again, we're going to add those top numbers together. 3 plus 4. Okay, going to give us 7 out of 5. This is okay because improper fractions are fine, they're allowed. It just means we have more than one whole. Okay, if you wanted to change this, this would actually be 1 2/5. We're not going to work too much with mixed fractions. Sorry, we're not going to work too much with mixed fractions this year. We're mostly going to be doing improper fractions because they're just easier to work with. But you just need to know generally what these are so you can understand it. Last one. Let's erase this, it's in the way. Okay, subtraction works the exact same way as addition, except instead of getting bigger, the numbers get smaller. So again, the two denominators are the same, 3 and 3, so we can put them together and the final denominator is still going to be 3. Now what we do is we take the 8 that we started with and we subtract 4, which means we're going to be left with 4. So we started with 8/3, took away 4 of those thirds, and we're left with just 4/3. Now, this is where it gets a little trickier when the denominators are different. Okay? This number is not the same as this number. The problem with this is if we try and add it, it can kind of get messy. Because if we had something like this, 1/4, and here we have 3/8, it's kind of hard to tell when you put them together how much will you have exactly. So what we're going to do is we're going to make them so they're both the same denominator. So for example, if I made them all 8ths, it would be really easy because we would just know, oh, 2 8ths and 3 8, well, we have 5 8ths in total. So there's 2 ways you can do this. If it's really easy to tell, oh, I could change this to be the same as that one really easily. Do that. I'm going to show you the other strategy on the next one. So in this, it's really easy to tell, well, if I just did times 2 over here, this would be the same. So I'm just going to multiply this. So this one, we're going to do equivalent fraction, would become 2 out of 8. This one didn't change, it stays the same. We're still adding these two fractions together. So when we add them, just like before, now the denominators are the same. So my final answer is going to be out of 8, and the top numbers just get added together. So this becomes 5 out of 8, and that's the final answer. If we have something like this, where it's kind of hard to tell, well, I don't know what to multiply this by to turn it into 3, it's not going to work. Here's the trick. You're going to multiply both fractions. You're going to multiply whatever number's here is what you're going to multiply here. So this is actually going to be times 3. Whatever number's on the bottom of this fraction is what you're going to multiply the other fraction by. So that one's going to be times 4. So now when we do our equivalent fractions, they're going to change. This is going to become 15 over 12, because we did 5 times 3, 4 times 3. This one is going to change. 2 times 4 gives me 8 on top. 3 times 4 gives me 12 on the bottom. What you'll notice is when you do the strategy, it always gives you the same denominators on the bottom, which is great because that's what we want to do. Now that symbol in the middle, the minus, we're going to keep that, and we're going to actually do it. So we had 15 minus 8 leaves me with 7. And again, when we subtract or add, the denominators don't change. So this is our final answer. Can't reduce it, so we're done. That's all I want to talk about with this. Just remember, the most important thing, common denominators. Make sure that the numbers are the same on the bottom. If they're not the same, like this one we just did, we have to multiply, make equivalent fractions to make them so they are the same before we can add or subtract.